All right, so anyway, that information for how to get into the office hours is at the top of the list of what we're doing for the week. So it's got the code and the password for the Zoom time, which is again from 2 to 3. So let's see here. John, coming to you real quick. John, how are you doing today, buddy?
Good. Tired.
Tired?
Yes.
Didn't get to sleep in today?
Yep. I woke up at 9.
All right. Well, hopefully you wake up a little bit, and I'll check back in on you in a little bit. All right?
Okay.
All right. So has anybody noticed on IXL an issue where you've done the work, but I haven't put the grade in? I've said that it's overdue or something along those lines. All right. So Izzy, it looks like you gave me a check mark, and Natalie gave me a check mark. So Izzy, I'm going to come to you real quick here. So you've been doing the IXL sections, but I put it in as overdue?
Yes.
All right. So if that happens to anybody right now, I've sent something to IXL because I'm having it happen to a couple of people in each class, and I'm trying to kind of narrow down who it's happening to. So I may send you an email and say, hey, if you're doing the IXL, just send me a screenshot. So if you're having that issue with me, it's not necessarily with me, it's with IXL, where IXL is showing you or that you've done that work, but sorry, I'm just taking a look at the chat here real quick. And so if it's showing you that, you've done it, you've got a score for it, do me a favor, take a screenshot of your score, hopefully with your name showing signed in, okay? So try and take a screenshot from the actual section so I can see your name at the top that you're signed in, and how many questions you've done, the time that you've done, and your SMART score. All right, because there is some issues with a couple of people in each class, like I said, and I think I'm starting to narrow it down, but I don't think I've completely got everybody identified that that's happening to. So it's not happening to everybody, but it's happening to a couple of people. So if you see me put something in as overdue, or it's happening to you that's has happened, just go ahead when you're done, take a screenshot of it, and just send that picture to me through Edsby, and I'll get that grade put in for you. All right. So Izzy, that okay for you then?
Yep.
All right. Thank you. All right. Did anybody have difficulty? Give me a thumbs up or a yes or something if you had some difficulty with any of watching the videos at all. All right, so Derek and Cassidy had some issues with the video. Let me just come to Cassidy real quick and see if it was more so Cassidy, was it an issue with actually being able to view the videos, or just having some difficulty understanding the concept?
Both. It was, so I think I figured out to get onto the videos. It was very glitchy, and then I just had a lot of trouble, and I still don't understand one of the videos.
Okay. So what we're going to do then today, thank you, Cassidy. What we're going to do then today is we're going to go over those notes that went along with it. So if you don't have those with you, go ahead and grab those. If you weren't able to print them, just have a piece of paper and be ready to kind of copy down some of this stuff. That's what should always be happening here when we are coming into a class where we are going to be going over some notes that we did prior, okay? So let me admit one more here. All right, just going to go to, all right, Cody. Cody?
Yeah.
All right, good morning. I'm going to go ahead and rename you and put your last name on here. All right, remember we want both first and last names on.
All right.
Come in. So I'm just going to go ahead and rename you. They've asked us actually to not admit people who have just a first name. So please make sure that you've got both starting next week, because otherwise I'm not going to be able to admit you if you have only your first name. All right.
I am.
Thank you, Cody. All right. So we're going to go ahead and get started going over those notes. Give me a thumbs up if you have your notes in front of you, or if you are have something at least to write with on that. All right, give me a thumbs up down in the reactions section. All right, Cassidy's got hers. Kieran has hers. All right, if you want to just send me a yes, I've got them in messages if you're having trouble with the reactions. But again, the reactions are down. If you look at the bottom section, the menu section where you can, where it says chat and things like that, you'll see some reactions, all right? All right, looks like we've got some people at least sending me some messages and getting thumbs up. So we're gonna go ahead and switch over to the screen where we're gonna go over our notes. All right, so we're gonna fill these in kind of as we go here. And on the lesson, these are called direct variations. They are types of linear functions. All right, they are specifically the linear functions that always go through that 0, 0 point, the origin. All right, so they're never going to go through any other point on this y-axis here, right? So if we're looking at where it crosses this y-axis, or even the x-axis for that matter, it'll always cross right there in the middle. All right, so it might have a different slope. It might be like this. It might be a negative slope. It could be technically even a horizontal slope of 0, but it's going to cross through that 0, 0 point. All right, so if at any point in these notes, if you got a question, just give me a raised hand. All right, and I'll try and keep an eye on that. Miss Carrie, if you could try and keep an eye on that for me as well, that would be great.
Okay.
So as we look at this, all right, the formula for a, all right, Noah's got a question real quick. Looks like Noah's been having some difficulty getting his audio connected on here. All right, Noah, did you have a question?
Yeah, so I had to go to the bathroom when you just started it, so I wasn't here for the beginning part. Did we do anything?
We just talked about some things with IXL, but again, anytime, and I'll say this to everybody as well, it's a good question, Noah. Thank you. So if you miss anything, if you have to go somewhere in the middle of this, you leave it running, you know, like if you need to use the restroom or want to go grab a drink or something, and you feel like you've missed something, keep in mind that these videos all get posted later. So if you missed, say, the first 5 minutes of the class because you came in late, you can go watch them on YouTube a little bit later. So these usually take a little while to get processed and posted because I do have a class right after this as well. So with the videos, they'll get posted usually before the end of the day by 3 o'clock, but they do take a little while to process. And because I got the class right after this, it's usually in that hour of, say, 1 to 2, where I'm usually trying to get those posted for you. So if you miss something, just watch the videos from there, all right? Okay, so let's go through here and talk about this formula. So the formula for this is y equals kx. All right, what this k is, it's called the constant of variation. All right, but direct variations are really just an equation form of what we would call a proportional relationship. Okay, so these things will always, if we just look at points within it, will always create a proportion. And a proportion, again, is just two fractions or two ratios that are equal to one another. So for example, when I'm looking at this problem here, the example that we did, 2 over 1 equals 4 over 2, right? Because if I just cross multiply, and that's how I can check if something is a proportion, if I cross multiply and do 2 times 2, is that equal to 4 times 1? And the answer to that is yes, right? They're both equal, 4 equals 4. So any direct variation will form a proportional relationship for this. So this k value is called the constant of variation, but technically what it is our slope. So our slope, we could just say that this is y equals mx just as easily as if we say y equals kx. So if you hear me referring to it as mx, it's because that k value is really just our slope value as well for that line, okay? So every graph of a direct variation will go through the origin, all right? That's the point 0, 0, all right? If the graph of the line does not go through that origin, then it may still be a linear function, but it's not specifically a direct variation, all right? We can find this constant of variation for our, or slope, as I just said, by dividing the y value in any point on that line by the x value for any point on that line, okay? So if we're practicing this, I'm going to zoom in on that section a little bit here, just so we can see it a little better. Just going to move this up some. Oops, too much. Sorry about that. All right, there we go. Okay, so we can see those points a little bit better on that. Let me get this off of the screen as well. All right, so the constant of variation, and then, so find the constant of variation and then write the direct variation function rule. All right, so any of these points will tell me the direct variation constant, okay, that k value or the m value. I could just count points just like I would for regular slope, but also I can just be given one point from a line and find its k value when it's a direct variation. And we'll look at that when we look at our IXL assignment for today. So let's take this point, for example. All right, 1 second. Let me just admit one more coming in now. All right. So welcome in, Jesse. We've got this point here will tell us our k value just as easily as this point. So I'll show you both over here real quick. Let me just scoot this over so you can see what I'm doing. So if I take the y value, which in this case is 6, okay, and that's from this point right here that I'm talking about, okay, if I do 6 divided by its x value, which is -2, it will tell me a value, 6 divided by -2 is -3. All right, so its k value is -3. If I use this point, I would find the same thing, right? 3 divided by its y value of -1, or x value of -1, would give me, again, -3. So it doesn't matter which point I use, as long as I'm not choosing 0, 0, because that's not going to tell me anything. But if I use any of these other points on the line, I can find my k value, okay? So now it wants me to then write the direct variation function rule. Well, that means I'm just going to write y equals kx, right? Well, if our k value is -3, I'm going to replace k with what I found. All right, so that would be my direct variation function rule then. All right, do we have any questions on that before we continue on? All right, let me just make sure we don't have any questions here. All right, so John, I said I was going to come back to you, so I'm going to come back to you here real quick. So John, can you tell me how we can find our k value, whether it's
Give me
graph or from a point? John, you there? Seems like John's microphone may have gone out, so I'm going to come to someone else on that question. All right, so let's see. Phoebe, I'm going to come to you real quick. So Phoebe, can you tell me how we can find our k value if we are either given a graph or just a single point?
This is
Maybe?
confusing to me.
I'm sorry, can you speak up a little bit? I'm having some trouble hearing you.
This is kind of confusing to me.
Okay, that's fine. Can somebody give me a thumbs up or a raised hand if they think they know the answer to this question? How do we find the k value from just a graph or a single point? And Phoebe, I'm going to come right back to you after we get a correct answer on this, all right?
Okay.
All right, Trevor's got his hand up here. So Trevor, how are we able to find our k from a single point or from a graph like this?
Can you repeat it again? Because it was kind of like glitching out.
Say that again?
I said, can you repeat that again? Because it was kind of glitching out.
Okay, so with a single point or from a graph, how are we able to find our k value for these?
Are we on the example?
Well, even if you want to use the example that we're looking at on the screen here.
Oh, okay. I thought I knew, but wait. Dividing the x, we can like.
Okay, so what is this value on the top up here?
That's the x value.
Is it the x value?
Or the y value, the y value.
Right, it's the y value on the top, right? And then on the bottom is our x value, all right, good. And so that's where our k value comes from, by dividing y by x. All right, good. Thank you, sir. All right, so Phoebe, gonna come right back to you like I said. All right, so let's see if I can locate you on here. All right, where did Phoebe go? Like Phoebe may have dropped out somewhere. Not seeing her. Miss Carrie, are you able to see if Phoebe's on at this moment?
I don't see her on anymore either.
All right, let's see. Oh, she's dropped out accidentally. Looks like she's coming back in here, so we'll wait for her to get logged in here and then come right back to her. Unfortunately, she may have missed the answer there. So before we come back to Phoebe, I'm going to go to Cade real quick. Cade? Good morning, Cade.
Yes. Hello.
So can you repeat what we said about how we were going to find that K value? So what's
I don't
this
know.
point up, what's this point up here? What part of the point is this number?
Is that the X value?
Is that the X value here?
Yes.
So if our points are X, Y coordinates, right?
Mm-hmm.
Is the 6 the X or the Y?
The Y.
Okay. And the -2 is the
X.
X. So we're going to divide Y by X, right?
Mhm.
All right. Let's see here. So now I'm going to come back to Phoebe. All right, Phoebe.
Yeah.
So what did we just say about how that K value is found from a single point there?
You would divide
Okay, divide what part of the point by what part?
on 3.
So what part is this 6? From this point right here, what part of the point is that 6? Is it the X or the Y value?
It's the X value.
So these points are listed X, Y, correct?
Yeah, it's kind of blurry.
All right, so see if I can zoom in on it a little bit more for you. Might still be kind of blurry. I think it's just a light printout there. So let me just go over it a bit with our pencil.
Oh, it's the Y value.
Okay, so that's our Y value on top. And then on the bottom is our X value, right? So if we
Yeah.
at division problem, we should find our K value, okay?
Okay.
Anytime we've got even just a single point, we can find our K value if they tell us that it's a direct variation, right? And if we're looking at a graph, we can tell it's a direct variation because it's going through what point? Frankie, going to come to you. What point are we looking to see on that graph to tell that it's a direct variation?
The origin.
Right, that origin. Good job. Thank you. Okay, so any questions on that before we go to the next page on this sheet? All right, Andrew's got a question. Let's see here. Andrew, what's up?
No, the thing that I was raising my hand for was to answer the question.
Oh, okay.
Answered.
All right. Got some other hands up here. So let me try and get to them in the order that I think they popped up. Cassidy, you've got your hand up. What's the question?
So that's what I got, the y equals -3x. So do we just not care about the x? Do we not need to find what x is?
Well, that's our function rule. Remember, function rules always have two variables in them, right? A y value and an x value. And so in this case, y equals -3x. We always, for a linear function, we will almost always see y by itself on one side of the equation.
Okay, thank you.
All right, so we'll look at how we deal with that function rule and use it here in a minute, okay? All right, Noah and Trevor got their hand up as well.
I had a question. So, like, right above the graphs of direct variations, there's like a fill-in spot, and I missed that.
Okay, I'll just scoot it down here real quick.
Okay.
So we've got those two words. All right, the direct variation is equation, should say form, not from on mine. of a proportional relationship, and that K value is called the constant of variation.
Okay, thank you.
All right. Thank you, sir. All right, Trevor, what's up?
Okay, so can we send the slope-intercept form before Tuesday? Or we have to send it, huh?
Oh, you mean for the homework assignment?
Yeah.
Yeah, you can send that to me anytime, it's fine. As long
But
as it's
it has to be before Tuesday. Or
yeah, as long as it's before we start class on Tuesday.
Okay.
All right, thank you, good question.
You're welcome, and thank you.
All right, let's see here. All right, let's go to the next page of these notes then. So this should be, if you printed them, your second page. So we're going to look at how this works from a table as well. So we can tell a direct variation from a graph because it includes that 0, 0 point. All right. So if our table also includes that 0, 0 point, then it's going to be a direct variation. And we can find our K value by simply dividing our Y by our X values for any one of these points. So for example, if I do 8 divided by 2, I'm going to get 4. That's from this point. Okay. If I do the next point down, I should get the same thing, right? 16 divided by 4 is also equal to 4. Or here, if I wanted to do this third point, it shouldn't matter which one I choose. I can get my K value from any of those points, okay? So if I find my K value, we're just going to divide that Y value by an X value for any of the points, all right? So for this practice problem, all right, it looks kind of similar to this. However, what we should notice is that our X values are bigger than our Y values, right? So over here, our X values were smaller than our Y values, and we got a whole number K value. When this happens, where our X values are bigger than our Y value, we should get a proper fraction or a decimal, perhaps, if you're using that way of writing it. So when we do 8, right, do Y divided by X. So we're going to do 8 divided by 16, all right? On this, then we could either divide it on a calculator and get 0.5, or we could just simplify this fraction. If we divide both of these by 8, we would get 1/2 as the simplified form of the fraction. Okay, same thing for any of these, right? 10 divided by 20 should also give me 1/2. 16 divided by 32 would give me 1/2 as a simplified fraction as well. Okay, so do we have any questions on that? All right, so let me just come to somebody we haven't heard from today, perhaps. Jesse, how am I able to tell, let me just come to you here real quick. So Jesse, how am I able to tell that I'm going to have a fractional K value? What about the X and Y points is going to indicate that I'm going to have a fraction versus a whole number, like in our example?
If the X is more than the Y.
Right, exactly. Good job. Thanks for paying attention there. So we've got X values bigger than Y values, so we're going to get a fraction from that. All right, when it's the other way around, we're going to get a whole number, or at least something greater than 1. All right, it might not necessarily be a whole number, but it could be, it's certainly going to be greater than 1. All right, Trevor's got a question. Let me come to him real quick. What's up, Trevor?
If we get a question right, do we get dojo points?
That's a good question. I'm not sure what's happening with our dojo points right now. Let me ask that question to Mr. Wolford to find out kind of how we're going to accumulate dojo points. But it's a good idea for sure.
Oh, okay.
All right. So I'll ask that question and find out. All right.
Okay. Thank you.
Thank you. All right. So let's take a look at this last practice or example problem, and then we'll make sure that we get to that last practice as well. So in certain situations, a direct variation actually exists in certain real world situations. So someone who's making hourly pay, for example, is a direct variation because they are getting paid directly a certain amount for every hour they work, right? So if in this example, right, if a job pays you hourly, the amount of money you make always is a direct variation to the amount of time you work, right? So we can make some predictions from these situations if we understand that that is a direct variation. We can use our direct variation constant and function rule to find missing information for future situations. So that's why they call it making a prediction, because we're trying to decide or figure out what's happening in the future. All right. So for this, right, we've got all of these situations, right? If this is our total pay, that's our Y value technically, and our hours worked is going to be our X value, all right? Because Y, remember, is always a dependent variable. It depends on X. So if the total amount of pay is going to depend on how many hours we work, okay? So we're going to divide Y by X. So let's just take this one, all right? And we do 135 divided by 15, all right? And if you take your trusty calculator there and we do 135 divided by 15, right? We get 9 as an amount, all right? But this was $135, so this is going to be $9 per hour is what that would be, all right? Because this is dollars up here and this is hours down here. So this is $9 per hour is how we could write the information for that. So if we put this over here, right, I'm going to call this Y and this is our X. So I'm going to write out a function rule here for this. Y equals, our K value is 9, so I'm going to use 9 for that, X, okay? So from there, I'm going to now be able to predict this total pay by plugging in this 25 for X, right? Because all of these worked is our X value and our total pay is our Y value. So for this, I'm simply going to replace X with the 25. So it's 9 times X. What would be 9 times 25? And 9 times 25 would be, and this is $9 again. So 9 times 25 would be $225. All right, so that's what would go there. Now over here, we can use that same rule, but now instead of replacing X, right, this kind of goes back to the question that Cassidy had about, are we only worried about what Y is or what X is? Well, in this case, we're going to replace Y and now try and figure out what X is. All right. So in this problem, I'm now going to say 810 for Y is equal to 9X. I'm still using this function rule, but I'm just replacing the Y value now because all of these in this column are Y values. So I would replace this. Now, how do I solve this one? Let me come to, let's see, who have we not heard from today? Natalie. How would I solve that equation there?
I don't know.
Okay, if we have 9 times X, remember how to solve that one-step equation? If we are doing multiplication, how do we undo the multiplication solving that equation?
Oh, you divide.
We divide, all right? Thank you, so good job. So we're gonna divide this by 9, right? And whatever I do to one side of an equation, I gotta do to the other. So I'm just gonna divide by 9, And I'm going to run out of space over there where you can see it, so I'll just move over here. So our x is going to equal 810 divided by 9. If I just do 81 divided by 9 and add that 0 back on, it's going to give me 90. So it's going to take me 90 hours to make that much money. Okay? So any questions on that example before we move on to the practice problem there? All right, looks like Trevor's got his hand up. Noah's got his hand up. I'll come back to you, Noah, in a second. Going to Trevor first here. All right, Trevor, what's up?
I don't got a question, but I got like more of a statement.
Okay.
I did, since I know that 100 divided by 9 is 900, I just, did 90 divided by, I did 100, I did 810. Wait, what did I do? How did I do that? I did 810 divided by 9, and that got me 90.
Yeah.
Well, it wasn't the same as, I didn't do the same as you did. I just did it differently. But I got the same answer though.
Okay. If that were, I mean, whatever works for you, however you want to think about it. It's basically just a division problem though, however you're doing it.
All right.
All right. Thank you. All right, going to come over here to Noah. So Noah,
could you scroll up a little bit?
Can I scroll up a little bit?
Mm-hmm.
For which?
The top one.
For the top example, you mean?
Yeah.
Let me just pull that down.
Thank you.
All right. So we're going to go to the next. Noah, you need me to leave that up there for a little bit?
No, that's good.
All right, thank you. All right, so let's go to the last page and look at that practice problem that goes along with this one then. So this is asking us to find several different things. All right, it wants us to find this k value first, write the direct variation equation or function rule, and then find these two pieces of information, this one that's missing here and this one that's missing here. All right, so this one's talking about gallons of gas and the total cost for that. So again, total cost of what you're buying depends on how many gallons you purchase, right? So this is our X value, this is our Y value. So for this problem, let's first figure out our K value. And we're gonna do that by dividing one number by another. I will tell you, I like this set of numbers here because dividing by 10 when we're dealing with a decimal is actually a pretty simple thing because all we got to do is move our decimal when we divide by 10, right? But you can choose any of these and divide them, but I'm going to use this one for that reason so that when I divide this by 10, I know I'm just going to move my decimal to the left, all right, making it a smaller number. So this decimal is just going to move one place over when I divide by 10. So I should get $2.75 per gallon, all right? Which these days, right now, seems like a fairly expensive cost for gas, but not too many of us are driving around right now, so that's probably why it's lower. So we've got this K value of $2.75, or if you just put 2.75, that's fine. You don't necessarily need the dollar value on it to write your K value. But to write our direct variation, we're going to say Y. If you wanted to use C for total cost, you could, right? But our K value right here is going to be that 2.75, and then X is going to be here, all right? If you wanted to use G for gallons or something instead of X, you could do that too. All right, before we get to that, anybody got questions on how we found the K value or wrote the direct variation equation? All right, looks like we're good on that. So we're going to come here to this one, all right, and I'm just going to use our direct variation equation to find this missing Y value. So our Y is what we're looking for. All right, we're going to use the 2.75, and then our X value for this is going to be that 18. All right, so again, using our trusty calculators, we're going to come and say 2.75 times 18 equals 49 0.5 is what my calculator tells me, but we're talking money here. So it's going to be 49.50. Add that 0 on the end for the money place, okay? So 49.50 is that. And then we're going to do this one where we're going to do the opposite operations of this, okay? So this is, again, our y value. I'm just going to do the work down here below it. So our y value is now 57.75, and that's equal to the 2.75x for this problem, okay? So once again, this is just a one-step equation where we're multiplying in the equation. So to undo that, to do the opposite operation, we're just going to divide by 2.75. All right, and on our calculators, we get 57.75 divided by 2.75. All right, give me a raised hand if you want to tell me what that answer is at this point. Hopefully you've already done this or you're doing it along with me here. All right, John looked like first hand up.
Okay, the answer would be 1.
John?
The answer would be 21.
21. All right, good job. Thank you. So we got 21 gallons is what that is, okay? Thank you, John. Okay, so that takes care of our notes. Does anybody have questions on the notes itself? Any questions at all? All right, so what we're going to do is I'm going to come back to here, and we're going to take a look at just one or two of our IXL questions, because I want to make sure that you guys are clear on how to do those before we move on to actually getting to work on those. So let me just share this IXL screen here. All right, not the IXL screen. There we go. So this is our IXL screen, or section, I should say. This is going to be in Algebra 1, all right? Not in 8th grade today. We're doing the Algebra 1 section for this. And R5 is that Algebra 1 section, right? So they want us to write and solve direct variation equations. Now, some of this you're not going to need to actually show the direct variation equation, but you'll need to use it to solve these problems. So I'm just going to switch over here to this screen so we can look at, because I think I just copied this on here. Let me switch to sharing this screen, actually. Whoops, sorry. All right, so my whiteboard is here. All right, so everybody sees that screen good? Give me a thumbs up if you can see that screen. Just want to make sure I'm sharing what I want to be sharing. Thumbs up. All right. If Cassidy can see it, John can see it, I assume most of you can. So, all right. So this problem here is 9, 18. So that's our XY value. And then they're giving us a partial point, and they want us to find that value for N. Well, N is technically, this is a Y value here, right? They're calling it N, but it's technically a Y value for that equation. So what we need is, first of all, our K value. Well, this goes back to what we talked about at the beginning, and finding our K value from a single point. So I'm going to come back to someone who was able to answer that question for us earlier, and want to make sure that we still have that information. Where did Phoebe go? Phoebe. So Phoebe, when we have a single point, how do we find our K value again?
Divide
Divide what by what?
the y value by x.
All right, thank you, great job. All right, so we're gonna divide this one here, right? Because this is the one where we have both y and x. So if I divide 18 by 9, it equals 2. So that's my K value. So I'm gonna write this function rule of y equals kx, but k is gonna be 2 for us here. equals 2x. Now here, this is sort of what we were just doing, where they're giving us an x value of 3 and asking us to find the y. So I'm simply just going to replace x with 3. Right? So my y value is 6. Right? So I'm just going to, when I do that on IXL, I would just type in 6 and get to the next question. All right, I will tell you that some of these are going to switch up on you. So pay attention to what you're looking at. All right, if they're giving you an x value and looking for y, you're going to do that. Now, if they had given us, instead of that point, let's say, for example, let me just switch to a different color. So if they had given us this point instead, where they were looking for n and gave us 6, right, we would be solving the same type of equation. So we would still find our k value from this one. But here in our function rule, we would be replacing y with 6 and looking for x. Okay, so if they do that, please pay attention to which one they're asking for and that you're plugging it into the right place. Okay, so if they're giving you a y value, put it in place of y in the function rule. If they're giving you an x value, put it in place of that x value in the function rule. All right, so some of these numbers will get a little bit bigger as you move along. All right, so please make sure to use your calculator to find the k value, to do the multiplication here if you need to do the division here if you need to. Okay, so does anybody have any questions on how that IXL section is going to work for you? I don't see any hands. So let's see if we can split up for the last 10 minutes here into some groups. And then, so let me split up into some groups here real quick so you guys can talk with each other in those groups. So I'm going to create rooms. So Miss Carrie, I'm going to send some folks with you.
Okay.
All right, so let's see. All right, so let's see. Let's see, why is this not doing it for me? Let's try this one more time, hold on. All right, hold on, let me just, this is giving me some technical difficulties here. All right, let's try this again. 2 breakout rooms. All right, so all right, here we go. Sorry this is taking so long. All right, I think I got that set. All right, here we go. We're gonna open these rooms up. Miss Carrie, you got a few, I've got a few, and
Okay.
we'll work on that IXL section in this time, okay, guys?
All right, so my smart score now is 41.
IXL.
So
Right, so-
if the y varies
We have to get 90 on this, right?
Yeah.
For real?
Algebra 1.
Yeah, 47.
Which one is it?
polar.
It's not.
I have no idea what to do.
Which
Same. I have
letter
no
is
clue how
it,
you do
Mr.
this.
Peters?
What's that?
R.5. Algebra
Which
1, R.5. It's Algebra 1, R.5.
R.5?
Yeah,
Yeah.
R or R5.
R5, okay. Yep, found it. Tank Trevor.
You about
Eh.
Oh, what? How? Mr. Peters, I need help on
I just got an easy one. I just got such an easy.
Mr. Peters,
Yes.
I need help. How do I do the direct variation?
Assume that y varies
Direct
directly
variation.
with x.
How do you say it?
If
Direct
one-
variation? That word.
Find
How do you find it?
Yeah, because the question that I'm on says if y varies directly with
Yeah, me
x and
too.
y equals 20 when x equals 5. Find y when x equals 1.
Okay,
I
so
can solve a direct
they're just
variation.
they're giving that to you as a more like a question than a point, right? They're not showing you a point, but they're telling you what x and y are.
Okay.
For one thing.
Mhm.
So you take your y value that you know and divide it by the x value that you know.
Okay. So
You
that
know,
would
I can
be,
use to answer all the
that'll be
questions.
4.
That'll
I can
tell
just
you the
use
k
Alexa.
value.
Okay, so I just write that, the k value?
No.
Then it
So let
says
me
when
see
x
if I can
equals
find
1.
one real quick, okay? Hold on. Let me see if I can find one and I'll show you.
Okay.
Because we don't know this right now.
All right, so
Like that one, yeah. Well, not that one, not the points.
Yeah,
just
not
gonna
that
use
one.
All right,
That
so
one, yeah.
Yeah, that
kind of
one,
like
yeah.
this
Oh
one.
my.
Yeah, kind of, yeah.
Yeah, it's that one.
Okay, so for a problem like this, all right,
It looks mega complicated.
what you want to do is take the y value. So in this case, I
Oh
would
no,
take,
that one was easy. I'm not used to
so I would take 16
16 divided by 2, which that
divided
equals
by 2,
8.
right? That tells me my k value,
Okay.
okay? So I would write my equation. So my k value in this case is 8, right?
Mhm. Right.
So I would write my equation of y equals 8x,
Mhm.
okay? And then I'm going to replace y with 8 and figure out what x is.
So it'd be 64.
Not 64.
Well, it'll be 1 then, because 8 divided by
Y
8.
for this one.
Oh, so what would I do? So
Let me
I'll
just
do y.
let me just switch screens and I'll show you, okay?
Yeah,
Okay.
please do that.
So let's see. Let me share this whiteboard again.
Okay. So I would do y equals 8x, right?
All right. So, for that problem, all right, you had let me just see. So you had so for example, the problem I had 16 for y and x was 2, right?
Mm-hmm.
So my k value would have been 8. So I would write this equation, okay? And then it tells me in the second part of the question that y is 8. What's x? Right? So what is x in that situation?
1.
1. Right? So x is equal to 1. Okay?
All right, thank you.
So the answer would just be 1.
Well, for the problem I had, yeah.
Oh.
Okay, then.
Every answer is just 1.
Well, not all
Okay,
of
so
them.
then
They're not all going to be
2
1.
divided by 5.
All right, so guys,
Yes,
we're
I'm
going
not that
to
slow.
wrap this up because I got about 3 minutes left of class. So if you guys, we'll get you back to the
Wait, I got one more question.
second, okay?
One more question.
I got it. Trevor,
Oh,
I
you
got
have
to
to
go.
multiply that
Oh,
again.
okay.
I can still talk.
All right, guys, we get like 1 minute left here, so I just wanted to say thanks for coming in again today. These classes run much better when we have some participants and participation. If you have questions, all right, keep in mind we have IXL work here, but if you've got questions, we're gonna be able to answer those further today during our office hours, okay? I don't have any more time right now because I got to go on to my algebra class that starts here like right now. So good luck. If you got questions or start to struggle, just hold off and come see one of us, either Miss Carrie or myself, at 2 o'clock. Okay, check my your Edsby page for all those codes. All right, have a good weekend, guys. Fist bump. We'll see you later.